Hello, and welcome to Apache TinkerPop's home here on Twitch. Today we have another TinkerPop Wide stream where we explore the wider TinkerPop community, looking at tools, libraries, or graph systems built on TinkerPop, on the TinkerPop framework, or even applications built on those foundations. Today we have Arthur, the founder of gdotv. Gdotv has been here before, and it's the Gremlin IDE, which helps make working with Gremlin easier and fun. So he's here today to talk about its latest news and upcoming features and improvements. Arthur, thank you for being here today.
Thank you. Thank you very much for having me. Yeah, I'm really glad to be able to present to you once again. I know it's been a while. It's been a very busy year, so I'm hoping today I can show you what I've actually been up to and what you can expect to be coming next for gdotv. So if you're all set, I guess we can jump right into it.
Absolutely. I'll leave it to you.
Excellent. That's it. So yeah, thanks for joining, everyone. So we're just going to cover some roadmap updates as well as announcements related to the product and the company. So just what we're going to go over today. Some updates that we've done this year to date. There's been quite a lot of changes. I thought it'd be a good opportunity to remind everyone of what's changed in gdotv, so that perhaps if you haven't yet, make sure you're on the latest version, because there's a lot of new cool stuff that you can benefit from. I'm going to try and give you a very brief overview of what I'm thinking is going to go in gdotv next year. Then we're going to cover some announcements of cool stuff that's been happening around gdotv. After that, I'll just give you a quick demo, and hopefully it'll go well, of some of the upcoming features, and we'll end with a little questions and answers section. So just before we start, quick introduction if you don't know who I am or what gdotv is. So my name is Arthur Bichard. I am the creator of gdotv. I've been working on gdotv for now about 3 years. gdotv is a Gremlin IDE, so integrated development environment. It's a product that you install on your device, Mac OS, Linux, or Windows, and that you can use to connect to Apache TinkerPop graph systems to write, debug, test, and analyze results for your graph database. So you use it, for instance, to view your graph or to write queries. Now, this year, there's been a lot of stuff going on. So gdotv is a piece of software that gets updated very regularly. I try and commit to a feature release about every month. And so I thought, since the last presentation was in February this year, that try and summarize on some of the stuff that went in since February. So the first thing, and it's usually the most important thing with all of the work that I do with gdotv, is that we've got some major user experience and performance improvement. Now, it's always a concern of mine to make sure that people that use gdotv get the best possible experience. And typically, the main two barriers to that best experience are, slowness and also just poorly designed user experience. And gdotv is something that I work on my own. So there's been some early designs here and there that really deserve some improvements, and I've focused a lot of time this year to improving this. We'll probably go over some of the changes in the demo, but generally speaking, the improvements are around the connection experience. How do you add your connection to gdotv? How can we make it as easy a process as possible, given all of the different providers that we got out there? So Janus Graph, Neptune, Gremlin, etc., etc. General improvements around the query editor, which is sort of the main backbone of gdotv. We want to make sure that everyone's got the best experience writing their queries, getting the right suggestions as they write their queries. But we've also got a lot of provider-specific new features. So this year, there's been a rather heavy focus on Amazon Neptune. Amazon Neptune has a lot of additional features that fit outside of the usual Apache TinkerPop space, and that we've been looking to support as much as possible in gdotv. So for instance, one really important one was the addition of single sign-on support. So if you're an Amazon Neptune user that works in an organization that uses identity and access management rules to connect to your database, and that requires to log in with your single sign-on provider, gdotv will seamlessly handle this, allow your IAM credentials to be refreshed automatically based on your authentication session. That just means a much smoother experience when it comes to connecting to those Amazon Neptune databases. That means, for instance, you don't have to regenerate your token regularly. update your gdotv connection with those new credentials and then run your queries again. Another one is the ability to view slow query and audit logs in Amazon Neptune. So whenever you run a query in Amazon Neptune, it will be logged. And if it's a slow query that's above a certain threshold that you can configure on Neptune, and I'll leave you to check the Neptune documentation on this, then Neptune will actually log in a special piece of logs called a slow query logs. It's a very important and very useful piece of information, and we thought it'd be useful for users to be able to access them directly within gdotv and to be able to trigger profiling and explaining of those queries. Another one, again, specific to Neptune, is support for their explain and profile API. So unlike other providers, when you want to run a traversal explanation or a query profile on Amazon Neptune, you have to use the Amazon Neptune API, which will allow you to receive some really detailed information on the profile or the traversal explanation of your query. And up until this year, gdotv was not capable of actually handling this properly. But with the updates that we've had this year, you can now seamlessly run a profile or an explanation of your query and get the results output exactly as the Neptune API would do. And that really allows developers to get to their profile much, much quicker. We also got a slightly trendy but nevertheless useful feature on gdotv, which is the integration of a generative AI Gremlin query feature. All that to say that with the rise of artificial intelligence tools, and particularly ChatGPT, as well as really interesting projects around LangChain, and again, some of the stuff has been contributed by Neptune there, we thought it'd be a really good idea to have users be able to just write a text prompt, get a Gremlin query, and get a graph visualization. So we added a little feature on gdotv that does just that. It leverages the data model of your database so that the query that is generated is relatively accurate to your model, meaning that it's not just going to try and make up labels and properties and other things. It will actually generate a query that is faithful to your data and most likely will work. This is an experimental feature simply because this is all very new. But overall, we're finding that it works really quite well and that you can get some really good queries out of it. So we're hoping that in the future, as these artificial intelligence models get better, we're also going to get much better queries generated out of them, with possibly a view of people just being able to query their database without having to entirely interact with the Gremlin language, which could be useful for less technical users. We're also making sure that we're always keeping up to date with the various versions available for different providers. So for instance, this year it's been quite busy. There's been a lot of work around JanusGraph 1.0. Now, to be clear, I'm not working on JanusGraph 1.0, but I have to make sure that gdotv is fully compatible with it, and is currently fully compatible with JanusGraph 1.0 release candidate 2. We're also making sure that we'll stay up to date with Apache TinkerPop related updates. So with a lot lately as well, with every Apache TinkerPop release, there tends to be new steps that are added. And so we want to make sure that these new steps are also supported in gdotv, meaning that they are recommended as you try and type your query. If you're on a version of Apache TinkerPop that supports these steps, gdotv will automatically detect that as well. Make sure that we include the documentation, because one of the useful things with gdotv as you write your queries is that it will display the documentation for the steps optionally, so that you can always refer back to those if you're not sure. We're also upgraded gdotv to Java 17. It's not a very important thing, but it does provide some considerable performance improvements. It comes at a very slight cost, which was that Graio serialization is no longer available in gdotv, but we're finding from users and from experience that most people are either using graph binary already, which is the recommended serializer, or they can switch back safely to graphson if graph binary is not available. And so all of that total is actually part of 8 different feature releases that have happened since February. So that gives us exactly a release per month. And we've got a few maintenance releases in between just to fix some little issues and bugs, or just simple style improvements. So that's what we've done in 2023 in a nutshell. There's quite a lot. I'm hoping that it's going to continue to be quite a lot of new features. And with that, I want to try and go over some of the stuff that we've worked on this year that is still to be released. So we've got hopefully 3 more feature releases this year. We've got October, possibly in the next week, November, and December. So in terms of progress, there's a few features that I've mentioned last time in February, and I want to try and touch on those and explain where they are and what sort of progress has been made. So the first one was the ability to have team functionality in gdotv. So in other words, the ability to share different settings with other users of your database. So what this will allow, for instance, is to save queries, folders, or style sheets directly on your database so that when a new user in your team, for instance, which is typically what you want it to be from, connects to your database with gdotv, all of those settings get automatically pulled down so that you don't have to create all these once again. So this is hopefully going to release in November, with probably a target release date of mid next week. So it's coming pretty soon. The other one that we've got is graph analytics functionality. So one thing that we want users to be able to do is to perform various graph analytics algorithms over their data. For instance, if you've got a large graph visualization loaded in gdotv, what if you want to run a community detection on your loaded data so you can see what communities are detected in your sample set, or you might want to run some centrality algorithms, pathfinding, etc., etc. Now, there's, of course, many ways you can do this. You can do this directly against your database via some of the provided steps if you're using an OLAP implementation, or you can use gdotv to just run these ad hoc and visually. So the idea is that when you run a graph analytics algorithm, you will not only get the results of the algorithm, but you also get an update to the visualization of your data that matches the information received from the analytics. The other one, and a sort of a silly one, but there are two graph views in gdotv. There's one that's commonly referred to as the graph view, and then there's another one that is referred to as the large graph view. Now, the large graph view is implemented using a framework called Sigma.js. And the big advantage of that framework is that it uses WebGL for rendering, which is extremely fast and very good for performance. One of the drawbacks of that framework currently is that it does not support curved edges. So in other words, when you've got two graph elements, two vertices connected to each other with two separate vertices, they will overlap. So one of the new features that's going to come in November is curved edges. And I know it's a simple, small one, but it's a really important one to improve the visualization. Now, there was a few other features that I've mentioned last time that are unfortunately not going to make it this year. So the first one was data modeling features, and this is heavily oriented towards Janus Graph users and the Graph Management API. So this is going to be postponed to next year, but hopefully next year what you'll get is the ability to generate Janus Graph schema scripts based on your data, based on visual editing of your graph, so that you can easily test and model your graph database and then configure it on your different Janus Graph clusters. The other one is the migration of the query editor on gdotv to a framework called Monaco. So Monaco, if you're familiar with Visual Studio Code, is the text editor that you get in Visual Studio Code. It's modern, it's feature-rich, and it's also very good for performance. And so we're hoping that next year, not this year anymore, we'll migrate to Monaco to basically unlock a lot more features around the query editor and to generally have a better user experience and one that people are more familiar with, because Visual Studio Code, once again, is a really popular IDE, and we're trying to emulate this look and feel as much as possible so that when users pick up gdotv, they feel right at home. So that's it for our 2023 roadmap progress updates. Now, the next thing I want to go over is what we're looking at for next year. Now, next year's roadmap is not fully fleshed out. Typically, that happens closer to the end of the year, and user feedback is a really important part of that process. So I'm trying to make sure that I hold that for as long as possible before I make some decisions on what's going to go. But one of the really important things that needs to happen next year is the version 2.0 of gdotv. So gdotv has been in development now for almost 3 years. And when I started development, it was on a technology stack that is now considered aging, namely Vue 2. And so what I'm trying to do is to upgrade this technology stack. There's a few reasons for that. The main one is that by migrating from this Vue 2 stack to Vue 3, I'm going to unlock a number of performance improvements for the software, which is always good to have. It means it runs more smoothly. We can do larger data handling, and generally speaking, it will improve the look and feel. The other thing that I'd like to put in, and I've not really touched on it yet, but we'll get to that in the demo, is more reporting features for gdotv. So currently, when you're using gdotv, you can very much just run queries, navigate your data interactively, show some graphs. And it's really useful. But what I'd like to get to is something more akin to what you see in SQL, for instance. So for instance, when you're using Microsoft SQL Server, you can configure stored procedures on your database that allow you to run frequent payloads, ones that might be useful for end users to view some of the data. There's no provision within Apache TinkerPop to do this kind of stuff, but there are ways for gdotv to configure and to save this information directly on the database so that users can get access to reports. A really important part of that is also going to be to improve the visualization options for results. So currently, when you're trying to visualize your results on gdotv, you're bound to just a few different options. The most obvious one being, of course, graph visualization, viewing your data as a graph. We've got some table views, so you can view your vertices and your edges, very much like you would SQL tables. And then you've got a raw output view that will just output the results of your query as you would see it on the Gremlin console or an adjacent serialized output. What I'd like to get is more complex visualization based on your results. So for instance, a really easy example here is that if you're writing a query, for instance, that projects properties from vertices effectively as a table, collection of objects with the same properties and values attached, I'd like to be able to display that as a table. If you're running a query that outputs a path object, I want to be able to display that path visually to the user so that they can see the actual path that they're fetching from the database rather than just a graph visualization that doesn't highlight the actual path being shown. The other one is that we're going to get some advanced graph visualization options for the large graph view. So I've briefly touched on that before, but this large graph view has some limitations in terms of what you can do for the design of the elements. A really simple example, for instance, is that nodes are circles in this visualization. You can have, for instance, custom shapes. Other problems are around configuration of borders or more advanced labels, or even just opacity of the node. So we're trying to incorporate some of these styling options that are currently available in the normal graph view, is using Cytoscape.js, into the large graph view. And this is all done with a view of eventually, with feature parity, getting rid of the graph view in favor of the large graph view with all of the features of the graph view. There's going to be further graph analytics features, once again, not released yet, but there will be further work on this. So this will essentially mean more algorithms that you can run with better visualization options. We're also looking to improve on the graph layout controls in the graph view. So currently, when you want to run graph layouts, you will essentially get a choice of a few different algorithms that are not necessarily named the best, and you don't actually get any customization options as to how you want to run the algorithms. So for instance, if you're running a grid algorithm, an algorithm that will output your graph as a grid with rows and columns, you can configure how many rows and columns you want. And so there will be more controls around that on various graph layout algorithms, so that users got a little bit more freedom about how they can lay out their data. Last but not least, and as always, performance and UX improvements. This is going to be a regular theme throughout. Every time something new is introduced in gdotv, there's going to be potential improvements that can be made, both in terms of performance and user experience, and we always want to be on the lookout for what we can do best. And then, of course, last but not least, is what users want to see. And I've also touched on that earlier. We're a very feedback-driven product. We want to make sure that we're delivering the best solution possible to our users. And so for that, we rely quite heavily on user feedback to know what you want next. So we'll get on that later, but if you have ideas, if there's things that you like to see in gdotv or other improvements, do feel free to get in touch, because we do listen and we certainly take into account what people have to say in our roadmap. Now, with all that out of the way, there's a few announcements for gdotv. There's been a lot of little changes for the company, I guess you can call it that. The first one is really simple, but we've created a blog. Now, the blog right now has just a few articles, but I'm hoping that as time goes, there will be more. You can expect to see regular articles around various graph systems. So for instance, we've recently released a blog post on Aerospike Graph. Other topics I'm interested in, so for instance, I really like Kelvin Lawrence's Practical Gremlin book. So I've done a little blog post just walking through reading the book and running some queries for gdotv. And there will be other, for instance, around Amazon Neptune and some of the advanced features that you can see. Generally, it will just be a place to learn more about what's happening in gdotv and what's happening around gdotv and some of the graph systems that we work with. The other announcements we've got is that we've created a newsletter. So once again, we're trying to communicate more regularly to users what's happening, what changes are coming, other interesting information. So for instance, in our latest newsletter, we've announced our partnership with Aerospike Graph, which I'll get on to in a minute. It's just a good way for people to find out what's happening without having to check in on the gdotv website or the blog every couple of weeks. So you can sign up for the newsletter at the blog page, which is also on the slides. But when you're signing up for a gdotv trial, you can also optionally opt in to the newsletter, so that if you want to make sure that you're finding out whenever there's a new update or other developments, you get it right away. The other thing super important is that we are sponsoring Sigma.js. So Sigma.js is a really important part of the gdotv software. It's an open source graph visualization framework that uses WebGL, as I've mentioned, for rendering. Is very powerful, very good performance, very easy to design. Now, with all that said, there's a few things with Sigma.js that we would like to see improved. And so what we've done is, now that gdotv is a paid software, we've used some of the proceeds from gdotv to fund further improvements on the Sigma.js framework. So I've discussed with the Sigma.js team based in France, and they already had a version 3 of their framework planned, and they were just looking for those days to work on it, which is what I'm essentially paying for in this. And those are some of the improvements that you can expect. So first of all, most important for us is improved performance once again. Now, don't get me wrong, Sigma.js is a highly performant framework, but we're always looking for how this can become even better so that we've got better interactivity in the user interface. The other one that I've also mentioned is the support for curved edges. So you will soon be able to see nice Bezier curves in your graph visualization. Some improved documentation, which we're not actually funding directly, but that the Sigma.js team will actually work on for this release. Sigma.js is a really, really good framework. It didn't have the best documentation as of V2, and so hopefully for those that are interested in building their own graph visualization application, you'll find that with this new version, you'll get a much better experience working with Sigma.js, which I can't recommend enough. We've also got better collision detection. Again, it's more related to performance, but the idea is that with this version, the collision detection on the graph, which is when you click on an element, how does the visualization know that you've clicked on this element, will be handled a lot better, and this will allow for more complex shapes to be rendered on the graph. So hopefully all of this should be out in 2023. For the record, I'm not the one working on it. The people that maintain the Sigma.js framework are working on it, and it's doing a lot of good progress. It's not quite ready yet, but we're expecting to have it out in the next few weeks. And now the best part, of course, is that this is all open source. So all these improvements that are getting funded on Sigma.js are going to be available to everyone. And I'm hoping that in the future, there will be further improvements that I'll be able to fund on the framework, so that once again, everyone that wants to build graph visualization applications will benefit from all this work that's being put together. So if you want to find out more about Sigma.js, I've put the URL there on the slide. Again, if you're trying to build any kind of graph visualization, go check it out. It's a really good framework. The other one is something that came up just a couple of weeks ago that I was not aware of, but a company called Datadog that specializes in security, endpoint improvements, and a number of other things, has released a little open source tool that they called KubeHound. And KubeHound is a really interesting case study, I guess, of how you can use a graph database and a graph visualization tool to provide some cybersecurity tools to companies. So what KubeHound does is it essentially runs a number of detections on Kubernetes clusters that a company has deployed. So it's a two-step process. The first step is it discovers all that information, builds it into the graph, and then it provides with a number of queries that you can run to discover potential vulnerabilities in your deployed applications. So this is actually powered internally KubeHound by Janus Graph. And in their documentation, they make a very, very heavy mention of gdotv as the recommended tool, which I've spelled as cool by accident on the slide there, to actually visualize all of the information. So again, it's just a really cool thing to see. It's really nice that companies like Datadog are taking ownership of the software to an extent to deliver their own capabilities on top. I'll actually show a little bit of that in the demo afterwards. The next thing is that we now have a partnership with Aerospike. So if you've missed the news, Aerospike has released a new graph database based on the Apache TinkerPop framework in June 2023. And we've been in conversation, since that launch and before, to try and make gdotv available. And ooh, shit. Right, sorry. Looks like we've got a problem here. Okay, so it looks like I've forgotten to share my slides, which is rather unfortunate. What I'll do is I'll make the slides available afterwards so that people can go through them. I'll do a very quick scroll through so that you can see them. Apologies for that little technical mishap. So just to really quickly go over it, quick introduction. Let's see here. Just our updates to date, which are all there. Roadmap progress as well. There we go. 2024 roadmap. The blog. Don't worry, there's not that much on the slides anyway. I just wanted to use it as a visual support, but you'll be able to come back on them. The newsletter, Sigma.js, which you've got a nice little screenshot there of Sigma.js, Datadog, and back to your spike graph. There we go. All right, so with that partnership, what we've done is Aerospike Graph offers a free 60-day trial, and we've decided to offer a free 60-day trial of gdotv along with the Aerospike Graph trial so that people can try the database with a proper Gremlin IDE the whole way through. So if you want to find out more, there's a little URL there once again that you can use. Feel free to check it out. It's all free, no obligation, so it's worth checking out. Now, the last thing, and it's quite important, is that we're going to be phasing out the gdotv basic tier. So you're probably familiar with the fact that gdotv has been free for a long time. We've eventually commercialized it for some, but not all of the databases. So currently, you can use gdotv for free, except if you're using Azure Cosmos DB or Amazon Neptune. Now, this is going to change in the future, and we are going to start phasing this out this year, and we'll eventually phase it out for everyone next year. So what will happen is users that are using gdotv for the first time from November will no longer have access to this free tier and will essentially need to use gdotv Pro instead, that they can get, for which you can get a free 2 weeks trial. All existing gdotv basic licenses that users are currently benefiting from will remain valid until February next year. There's going to be a separate free tier called gdotv Lite that will be available for the in-memory graph version of gdotv, which is the gdotv playground, so that people can still use gdotv and learn graph databases, load their data sets, query, albeit in an in-memory graph. And then all the graph systems that you connect with gdotv will require a gdotv Pro license from February 2024. So for instance, if you're a Janus Graph user using gdotv today, you're still going to be able to use gdotv entirely for free until February next year, but then from February next year, that will be revoked and you'll need to look into getting a gdotv Pro license. So the reasons for that are essentially that in order for gdotv to continue running the way it is and hopefully expand, we need to have more people on the team. And we're hoping that with the revenue that this could generate, we'll have all that to us. So you can expect more features next year and better support, more improvements quicker as it goes. So now we've got all that out of the way and my screen is sharing, we can go for a little demo. So what I'd like to demo today is some of the upcoming features for gdotv. So first of all, we've got the team features and the parameterized reports, which will hopefully both release in November. And then a very small preview of the graph analytics feature, which is still very much in the work, and that we're hoping to have a first version of in December. So let me just switch to my gdotv screen right here, and hopefully it's all showing. Let me just reshare this. There we go. Okay, so that should be gdotv now showing, and we've got a little query there on the screen. So the team features for gdotv that are going to release next month are around queries and folders. So in gdotv, you can actually save queries and you can organize them into folders locally. And what that allows users to do is, save their favorite queries, run them whenever they want. The problem with that is that those queries are only available locally on the device. So if you're telling your colleague to, use all of the same queries, they'll then have to go and recreate them locally, which is a little bit painful. So what we've done is we've created a new feature that allows to save all this information directly on the database instead. So that when a user connects to the database, it also pulls down all that information automatically so that you can share all of this information directly with user. The end goal is that if you've got a graph database that is, for instance, released in production and that you want to provide reporting features for that database, you can create all of these queries within gdotv, save them remotely on your database, and then whenever someone needs to run a report on gdotv, they can simply connect to the database. They'll have all the reports neatly organized on the left, and they can just one-click run it. So that's the first thing. And this will apply for now to folders and queries, and eventually, hopefully in December as well, to graph style sheets as well, which is what you use to configure how the graph looks. Stuff like the color of the vertices, the actual label to be used on the vertices, etc., etc. So what I've got on screen here is a little query that is actually from the KubeHound database. So I've got KubeHound running locally with a sample data set, which I'll very briefly show the data model for. So this is what you've got in the KubeHound data set. You've got nodes, pods, volumes, etc., etc. And what KubeHound does is on their documentation, they publish a number of query that you can run to find the vulnerabilities based on the data that you've ingested in KubeHound. So it's a really good example of where those saved queries can be helpful. And so what I've done is I've created a folder called attack path with one query there called known endpoint vulnerability. Now this query is actually set up as a report, which is a new feature that will release on gdotv next month. And the idea behind reports is that you can create variables on your query that user can then be prompted for when they want to run the report. In other words, you're creating the report as an engineer, for instance, and when you want normal end users that don't actually know how to write Gremlin queries, they don't have to write Gremlin queries. Instead, what they can do is they can just run the report on gdotv, enter the values of the variables for the report, and receive a graph visualization. So for instance, this report here currently has just the one parameter called the known risky endpoint name. And if I run it, what we'll get is a little graph visualization, which is the actual query being run from the report with the values of the parameters. So right now, what we've got here is a little path visualization that is highlighting the minimum path between a known vulnerable pods and a container. So if we go back to the query there to look at how this is set up, it's actually really simple. What we've got now in gdotv is support for these little special tags in your queries. Now, what those special tags do is they're effectively variables. When you add a new tag on your query, so for instance, here we've got a repeat of up to 6 hops on the query. If I want to make this configurable in the report, then what I can do is create a new tag, which I'll call max hop count. There we go. And you'll see that as I'm typing the variable, it's now showing up in the Gremlin query assistant there on the right. So the idea is that we're parsing the query in real time, detecting these variables. Then when we see these variables, we're presenting them to the user to say, hey, you've got a variable, what's the value for it? And the other thing you can do is you can actually specify a default value, for instance, for the variable, which is what will show by default when the user tries to run the report. And you can specify a label for the variable so that when you're presenting this to user, once again, it doesn't have to be the actual variable name. It can be a simple explanation of what they're actually trying to run. So I'm actually just going to call this one max hop count as well, because that makes sense. I'm going to save this. Now you'll see if I try and run the query here, it's not going to be happy because it's missing the value. So I'm just going to enter this. I'm going to set this to 2. And I believe what we'll see is nothing, because 2 hops is not enough to get the right information out of this query. But what I can do when I'm running, for instance, my report, which I'm going to rerun now, is I can specify a different max hop count. So for instance, I'll set up to 4, and we've got a visualization out of this one, and I can change this at any time. So for instance, I can edit my parameters, and you'll see this is actually a slightly different visualization to the previous one. If I edit it now, set to 6 hops, once again, you'll see now that we've got a little bit more information because we've got a few more hops. So if we're counting from here to here, 1, 2, 3, 4, 5, you can see how we ended up with a few more elements on this query. It's a really useful way to present, easy to run reports for users. So this version currently will support creating those reports, adding default values for the variables and labels. What we're hoping to do in the future is add a few more functionality around suggestions for report values. So for instance, say you've got a query in which one of those variables could be a choice of 3 different things, like JMX or HTTP or SSL. Then we'll allow users to configure these options, and then when a user tries to run the report, they'll simply be presented with a dropdown of these options. We'll also have different types of variables. So for instance, simple one is a Boolean or a number. So it's going to get more complex, and it's going to allow for a richer and richer user experience as time goes. The other thing, and I can't really demo it very easily here, is that all of these folders and queries are actually saved directly on the database. Now, the way it works is really simple. It actually creates some vertices on the database that contain all of the information that gdotv needs to parse and run these queries. But within gdotv, it's a quite seamless thing. So for instance, when you look at your data model, you're not going to see those special gdotv elements on your database. It's not going to pollute your query writing experience. So for instance, if I'm writing a new query here and I want to, filter on a label, for instance, then I still will get the labels pertaining to the actual data available, but it won't show those special gdotv labels. They do exist on the database. So for instance, if I query for gdotv folder, you'll see that do get results. But they're also explicitly filtered out from the graph visualization. What that means is you're not going to have these little random outliers on your visualization that are just gdotv settings. And it just keeps it all nice and tidy. The other good news is this is going to be compatible with every graph system. For JanusGraph specifically, because JanusGraph implements schema constraints, it will be a requirement to run a couple minor scripts to create the vertex labels and the property constraints on the database. But gdotv automatically detects if those are missing. It will actually pop down the script to run with an option to run it directly against your database to configure the model. So it's all meant to be very easy to configure and very easy to put together on your data with minimum impact to the actual data footprint on your database. So that's about it for reports and for those team features. As I've mentioned before, eventually the style sheets that you see here will also be available to modify and to save on the database, so that, for instance, if you got your own style sheets already configured, you don't want to have users reconfigure them every time. then they'll also be able to load them automatically. Now, for style sheets specifically, you can actually export or import them out of gdotv, but this is just another step further to make this easier for the user. We're thinking about situations where we've got 20 people working on the same database. We don't want to have 20 people having to repeat the exact same steps of creating the queries, creating the style sheets, etc. This just saves a lot of time. It means a much smoother experience and a lot less configuration. The other thing I want to show you today is Graph Analytics. Now, Graph Analytics, for the record, is not fully fleshed out as is. So what you're going to see is a dev version. It's not going to be super pretty, but it will hopefully highlight what I'm trying to achieve with this and what you can expect. So with Graph Analytics, you're going to have a new tab on the large graph view, named the same. And what it will do, and apologies, this is not fully fleshed out just yet because it's a dev build, but you'll get an option of a few different algorithms. Descriptions will be popped in eventually on this that you can run by just specifying a few parameters. So for instance, with this one, you can run a community detection on your data as displayed on the screen. So I'm just going to give it a very simple name there of community detection. You can adjust on some parameters. Now this one here, there's no edge property, so there's no way to provide actual edge weight properties for the algorithm. But if you've got a data set that has edges with numeric properties, then you can potentially leverage that. We've got a resolution parameter that allows you to determine how many communities that you will actually want to generate from this algorithm. If we run the analysis, what you'll see is the results of the analysis that are highlighted here, but also data being laid out according to the results of the algorithm. So the instance of a community detection, what you've got is communities being sets of vertices are highly interconnected by edges. And so those communities, as you can see, are neatly organized in the display and available to see on the right-hand side. So for instance, you'll see that the biggest community we've got is the one around this specific vertex, which is an account with this number. And so if we zoom in, we can quickly see, there's a lot of stuff connected to it. So for instance, this one here is connected to two big merchants that are themselves quite highly interconnected, hence why it's the highest connected community. This isn't the only algorithm we've got. There's a few more there that we can demonstrate, which I'm going to quickly go over. So you can easily discard the analysis, return to the way your graph was. The other one that I've got here is centrality algorithms. So I'm going to use PageRank, which is probably the most commonly known one. And what PageRank will do is it will generate a PageRank value for each vertex, which is essentially how, again, highly interconnected it is. And gdotv will use those values to size the vertices accordingly. So the idea is that in this visualization, for instance, the vertices with the highest PageRank are going to be the vertices that look the bigger on the screen. And the vertices with the lowest PageRank will look the smallest. So within the context of PageRank, for instance, you'll see this little area here is quite small. And this is because we've got a small cluster that is completely independent, not connected to anything. Whereas if we go and look at, for instance, these merchants here, you'll see that they're highly interconnected. They've got lots of transactions attached to them. They're also connected to a number of accounts and customers, and they're therefore bigger on the graph. So that's the idea behind all these. There's going to be a few more algorithms that are going to be added initially. This is also heavily leaning on the upcoming Sigma.js upgrade to v3 that will provide all these performance improvements. The idea being that the more elements we can render on screen, the bigger analytics we can run. So that's it for the demo today. Hopefully this is all really helpful and insightful. This is all coming very soon. So hopefully by the end of the year, you'll have access to all this functionality. So I'm just going to return now to the presentation, and we're going to go over a couple more things and then close for questions. So let me see, slideshow. And there we go. Okay, cool. So now we're done with the demo. Let's go back to the rest. Now, just to wrap it all off, support and improve gdotv. It's really, really helpful for us to know what users think. The more you tell us, the more you can expect to see in gdotv. So one thing that I always want to hear from people is what they want to see next. And some of the things you've seen there on screen are essentially what a lot of users have asked for. What should be improved as well? If something doesn't feel right, something should be better, or you've got an idea of something that gdotv could do, let us know. you can contact me directly on the Apache TinkerPop Discord. You can email me as well. Of course, financial support also helps. As you can see, hopefully, what we get from our customers allows us to fund better versions of gdotv and to also fund some of the dependencies of gdotv, such as Sigma.js, that everyone else can benefit from. Sigma.js is an open source framework, and all of these funded works will be available to everyone. If you'd like, tell us a little bit about how you're using gdotv. Send us a little testimonial. What are you getting from gdotv? Does it benefit you? It'll be really useful for us. Again, this is something that we can potentially share with other customers so they know why they should use gdotv. You can also follow us on Twitter, which is now called X, at gdotv_ltd. Typically, what we'll do there is we'll post little dev previews, other announcements that are somewhat similar to what you'll see on the blog or newsletter. On Twitter, we tend to focus on more rough work. So dev updates typically are showcases of stuff that's happening in gdotv that's not quite ready. That gives you a good idea of what to expect. And last but not least, of course, tell us what you like about gdotv, and especially what you don't like. If I know what you don't like, then I can make sure that it's getting worked on so that gdotv continues to improve. So yeah, a little plug for gdotv. You can get a free 2 weeks trial of gdotv, or 60 days if you're using Airstrike Graph by downloading it at gdotv.com. You can still get the free version of gdotv as of right now. So if you haven't yet, go and download gdotv, go and install it, get your gdotv basic license. It will remain valid for several months. You can purchase a license if you need it, or if you would like to purchase one at gdotv.com/buy. And if you need more time on your trial, just let me know. I'm quite happy to provide as much time as needed for people to trial the solution and get the best out of it. So yeah, that's it. Thank you very much. If you got any questions or comments, please let me know. I'm happy to help.
All right, thanks, Arthur. That was you definitely showed us a lot there today. I think we'll give folks a chance to see if there's any questions. I guess in the meantime, maybe I had a couple while I was listening there. And by the way, so sorry, I didn't realize you were talking to the slides and live.
Yeah, I just ran with it, man. That's what happens when you're presenting your notes.
Well, you said
unfortunately it wasn't a demonstration. I think it would have been a lot worse.
It was about the time you said there was a spelling mistake on the slide that I was like, oh, he's so
no harm done. I think we've
Sure.
got visual anyway. And I'll make sure to share the slides so that people can see them. But to be fair, the main information I think is in the demonstration. That's what I wanted to convey the most. So we've got that on screen.
Sure. So I think I can understand I like the report thing. I was just wondering, so you're storing some data on the graph itself, which is I guess probably the most obvious place you would go and store that. Do you think there's issue with like users who might not want their production graph to have that data in it, or do you think like users don't quite use g.v in that fashion? Like, are they using it against like a subgraph, a subset of the graph, or like how do you, what do you think about that?
So that's been a really difficult decision, and I actually have been thinking about it, and I've been mentioning those team features for well over a year now. And what it came down to for me is I've got two ways of doing it. One is I expose a separate service that people can sign up to within gdotv, where they can store this information. Hello, doggy. Or the other option is to try and leverage the database itself. Now, the problem with leveraging the database itself, of course, is that there's no way to actually store this, natively, if you will. But the advantage of it is that if I can store it on the database, then it's a lot easier for users to manage. It's a lot easier for gdotv to load. For instance, if I'm exposing an external service, then I have to host user data, right?
Right.
I don't know what's going to go in these queries. It could be sensitive for all I know. People might be reluctant to rely on infrastructure that is not theirs. So it's just been a bit of a compromise. Now, the good news is that the overall footprint on the graph database of these settings is pretty low. So it's pretty much a one-to-one. So for instance, if you're saving one query on your database, it's going to result in one vertex. If you're saving a folder, it's going to be another vertex. I had to make a conscious effort of keeping the data as simple as possible. So for instance, you'll see maybe if you use this feature in query, that there will be no edges between the data. So for instance, despite a query, for instance, belonging to a folder, within this feature is not going to be represented as such because the footprint is much lower if I'm only creating new vertex labels as opposed to vertex labels and edge labels. I've also made sure to use property names and label names that are highly unlikely to occur on the database. Long story short, everything is prepended with g.v underscore. That's again to make sure that if someone is, for instance, running a query, say a global search that looks for a property name on their graph, they're not going to find a g.v label in there. So this is the compromise I had to come to. Hopefully, in production, we're not going to see any issues. What I've had feedback-wise from customers, because I've been discussing this, of course, with customers prior to developing it, is that there should not be an impact, but g.v will be documented accordingly to make sure that all these things are mentioned. And if in the future there happen to be some changes on the framework or some better way of doing it that remains, that keeps on the database, then I'll be making sure that this is supported as well. I guess one thing that I've seen, for instance, on Airspike Graph is that they have virtual vertices on their database. They are not queryable through normal means, but that can be queried specifically by ID. This is the kind of things that I think potentially could work quite well for g.v. But the reality of it is there's many graph systems. They all evolve at very different paces. Looking at Azure Cosmos DB there, for instance. So I have to find this sort of middle ground between all the solutions. But if something within the framework opened up that allowed for this type of payloads to be handled more smoothly, then I'll definitely look into it as well. So yeah, difficult one, but hopefully this will be a good compromise for all the users and the graph systems as well.
Yeah, I mean it makes sense. I'm sure that was a hard choice but what
it took me a year to get to kept coming back on it.
The other question I had, which I think may be an obvious one, you touched on the analytics side of things. Do you have any sense of how large a graph you can comfortably run these on at this point? Or are you still waiting for Sigma.js?
So this is actually another reason why I've commissioned all this work on Sigma.js. It really depends on your device. Now, typically, I want to think of people running g.v on a normal device. So, for instance, I've got a MacBook here, right? A MacBook Air. That's what we'd consider a normal device for an engineer to run on. On this kind of device, you can reasonably expect g.v to render and run analytics on tens of thousands of elements. So typically, if you look at the air routes graph, for instance, which is about, I believe, 60,000 elements, if I remember correctly, that's a good sort of amount, and that's about as much as g.v can render. Now, with the Sigma.js improvements, I'm hoping to push that number closer to 100,000 and above. The idea is that in combination with those improvements to Sigma.js, with the graph analytics feature specifically, there will be other toggles that will allow to increase the graph performance. So typically there's a trade-off, right, between what you see on screen and how much detail you display and how much this is going to cost to render. So if you strip some of the information from the graph visualization at a certain zoom level, for instance, you can really, really improve the performance. And g.v already does that with labels. So for instance, if you're zoomed out of the graph, you can have it so it doesn't display labels unless it's a really large display of the vertex. But it doesn't actually automatically try and do this stuff. It just sort of has a default value. Maybe it'll work, maybe it won't. And I'm looking at ways to automatically detect the size, the shape of the graph, to determine what are the best settings to use. And that also applies, for instance, to the graph layout algorithms as well. So what I can say is that today, we're looking at tens of thousands of elements, but next year I would quite like to be, at least at 100,000, if not more. This is obviously not going to be suitable if you're trying to run the graph analytics on millions of vertices or billions of vertices. But generally speaking, if you're looking for this kind of graph analytics payloads, you're not going to want to do it through a client. You might want to do it directly against a database using, an OLAP implementation. That being said, I am also interested in some of what Graph Notebook, AWS Graph Notebook does. because if you're not familiar, for people who are viewing right now, AWS Graph Notebook essentially offers the ability to run Jupyter notebooks against the data, and this is really useful. And actually, this is one of the things that I mentioned quite a lot for graph analytics work, because it uses Python, which is much better in general for this sort of like heavy duty work, where I expect that you could potentially load a lot more elements and run these analytics on larger sets of data. The only trade-off, of course, being the visualization related to it. But this is something that I'm keeping my eye on, and I'm trying to find out, based on user interest, if one day having the ability to run a Jupyter notebook on gdotv to perform really, really like developer-centric graph analytics would work as well. I've not heard anyone so far come up with this, but I'm hoping that if I've got more time and more people working on this, that potentially this is the type of feature that could be done as an exploration, that you offer it to users and then users go and do what they can with it. So yeah, that's generally the situation there, and I'm hoping it will get better and better as technology improves. And tomorrow I might say, hey, go and deploy this VM on AWS with this much GPU, CPU, blah blah blah, and you'll be able to run up to 500,000 elements. There's a bit of benchmarking there that I'm needing to do, and that hopefully if I do, I can share results stuff as well.
Yeah, I don't know. It might be a nice use case too if you had a big, like a massive graph. If you could easily somehow subgraph directly from g.v and get your subset there and do your analysis.
Yeah, and that's a really interesting point, because this is something I thought about, and that would work quite well with the gdotv playground. So gdotv playground is just an in-memory graph, but I think with subgraphing, what you essentially get is also a graph instance that I could then potentially plug in to be queried as a separate instance of your data. I have not been able to investigate it much, but I can definitely see the potential for subgraphing some of your data, storing it locally on an in-memory graph, for instance, and then running analytics algorithms against that data, running queries against that data. The trade-off, of course, being that if you're saving the data locally, then it won't be in sync with what's available remotely. But there most likely are use cases where it's suitable. If you're performing analytics of records that are already sent your data, and you just want to, now that you've got them in, analyze them, I think it would work quite well. I think off the top of my head, possibly a good use case for this would be, and apologies because this is a Neo4j topic, but the Paradise Papers investigation, which I think is something that they've talked about quite heavily, and for good reasons. It's a big data set, hundreds of millions of vertices and edges mostly, in fact. You can imagine this being a good type of data set to subgraph from and to then perform analytics. So yeah, I can see the potential there for sure.
Yeah. Okay. There is a question from Twitch, specifically from Cole Greer. Are there any upcoming changes or features in TinkerPop which you are looking forward to for g.v?
Yeah, actually, first one is that already came out, but I gotta say it's great. Is in 3.7.0 the ability to get properties directly with the elements. I gotta say, honestly, the performance improvements on gdotv Playground from this was just phenomenal. Up until that stage, gdotv had to load those vertices and edges and then run queries to load those properties, which is super expensive and just slow. I'm really excited to see providers get on board with that. Now, for me personally, what I'm really excited to see in TinkerPop is a lot of the work that you guys have been presenting lately on all these additional steps. The concatenation of string for me is probably the main one. I know it's already out, but there's also list management. One thing I'm interested in, I guess, and I suppose I've not really talked about it before, but it sort of relates to those remote capabilities, and I quite like the ability to create records that are in the database, but not in the database at the same time. And I don't really know what the right answer for this is. But I'm thinking about, for instance, when someone connects to a SQL database, which always come back to because SQL has been around for longer than I am. And a lot of people that come to Graph might have started on database with something like SQL as, hey, I can have stored procedures on SQL. And that means whenever someone connects to the database, they've got stored procedures that they can run quite easily, this kind of stuff. So as you can see right now, I'm having to do that manually, but I'd quite like for that to be potentially part of the standard. That being said, anything that relates to new steps is always really exciting for me because that gives me an opportunity to rework the suggestion engine slightly.
Yeah.
Props to the merge E and merge V step, which are a total nightmare actually for the suggestion engine. I've not quite worked out yet, but these are already great because they're a good way of like showcasing a graph database, what it can do. And I think in conjunction with gdotv, I would say, hey, look, this is how you fetch all the name. You concatenate your first and your last name on this user. You could display a list of all this information. You could, for instance, quite easily create a query that creates CSV records, right? With concatenation, you get all your properties, boom, you output it as a CSV. There's a lot of cool stuff you can do there, and I'm always excited to see these features, and especially what people do with them. Ironically, I don't work with graph databases that much. I just make software that works with them. So I don't really get to come up with really cool queries, but I always like to see people coming up with cool queries and then, show what they can do with it. And that usually is useful for me as well, because I'd be like, hey, maybe I can do some version of that query in gdotv to present some information in a better way. So yeah, definitely always excited to keep up to date. And I always make sure that gdotv releases are quick, when it comes to framework updates. If there's TinkerPop 3.7.1 releasing, you can expect it to be on gdotv within 2 to 4 weeks typically. I always slide it in somehow.
Yeah, that's great. That's great. Cole mentioned in the chat there that he's kind of felt that there's a room for some sort of like off-graph metadata service in TinkerPop. So yeah, definitely.
There are variables for the records. The graph variables are a way to do it, I guess. The problem is I have to find something that works across the board.
Yeah.
That being said, I think I can start moving into provider-specific implementations as time goes. I think it will make sense.
Yeah.
So it'll be, for instance, if Amazon Neptune supports graph variables, then maybe I could leverage those instead, or
right.
That kind of stuff.
Yep. Okay. Well, I think that's about it for questions and comments. Thank you so much for doing this. Very
Thanks for having me, as always.
Yeah, very
Sorry for the
informative.
presentation mishap.
Yeah, I kind of should own that one too a little bit.
We'll fix that in post-prod.
Yeah, exactly. All right. Take care, Arthur, and thank you everybody today for joining. We'll see you at the next one.
Take care, everyone. Good to see you again.